go for the derivation for the formula NPR. Okay, I have told you NPR is the number of permutations of n objects taken R at a time, right? So here we are going for the derivation. Already I have given this. NPR is equal to n factorial divided by n minus R whole factorial, where R has this condition. Okay. Now see, for derivation we have R n given objects and we have to take R at a time. So consider how many vacant places. N objects are given, right? So consider n objects which has to be arranged in R vacant places. Okay, be arranged in R vacant places. So I have to create R vacant places now. So let me consider those R vacant places like this. Okay. So here we have R vacant places 1, 2, 3, 4, so on. Here it is R place. Okay. In general, so it is first place, second place, third, and this is fourth, so on. This is a R vacant place. So there are total R vacant places here. Okay, now what we have to do? We have to arrange these n objects in these R vacant places. Okay. So here what I do is first what place here can be arranged in how many ways? There are n objects, so I can arrange or I can place this vacant place can be arranged in n ways. Right. Now see, here the things cannot be repeated. Okay. Repetition is not allowed here. Okay. Repetition is not allowed. I told you in the beginning itself. Right. So repetition is not allowed. Therefore, the next place, okay, second place can be arranged in how many ways? See, n objects are available. One of them we are taking here. So next place can be arranged in how many ways? N minus 1 ways we can arrange this. Okay. Now the third vacant place can be arranged in how many ways? Or we can have the vacant place, it can be filled in how many ways? It can be filled in n minus 2 ways, because n objects are available but 2 of them already went here, are fixed here. So here this can be arranged in, or this can be filled in n minus 2 ways. So on, and next place, and obviously it is n minus 3. So on. What about this rth place? Okay, how to find out that? See, the first place in n ways, second place n minus 1. Compare the relation between this. 1 less than this place, right? And here you see 2, here 3. So 1 less than the respective place. And here 3, 1 less than the respective place. It is fourth place, it can be arranged in 1 less than that, n minus 3. So rth place can be filled in how many ways? N minus, for R it is 1 less. So these many ways I can arrange. Okay, it can be filled in these many ways. So again I will tell you, first place in n ways, second place n minus 1, relation between this is, here it is 2, here it is 1, and third place in n minus 2 ways, so here it is 3, here 1 less than that, and fourth place can be arranged in n minus 3. How did you get 3? It is 4 minus 1. Like that, rth place can be arranged in n minus r minus 1 or 1 base. Okay. So this is equal to what? It is n minus r plus 1 we get. So it is n minus r plus 1 base. We can arrange the last place here. Okay. So that is about the formula. Okay. So I can write, therefore it can be written as number of permutations of n objects taken R at a time can be given as n into n minus 1 into n minus 2 into n minus 3, so on into so on. Last one is n minus r plus 1 ways. Okay. So this is about the number of permutations of n objects taken R at a time. This is by FPC, right? By fundamental principle of counting, these different vacant places can be arranged in so many ways. Now see, suppose, to remember this formula will be difficult. So what we have to do here is, I multiply and divide, okay? Multiplying and dividing through by, or to get this formula, see, numerator we have n factorial. See this numerator, it is, denominator is 1, numerator has n into n minus 1, so on till n minus r plus 1. How to convert this numerator into n factorial? I have to multiply the next terms here in natural numbers. The natural numbers which are next to this till 3, 2, 1. Right. So multiplying and dividing by what? N. See, which is the next term here? See, here we know the next terms come by reducing 1 less than that. Right. So reducing by 1. So here, this is the next term. Reduce this by 1. So you get n minus r plus 1 minus 1. So you get n minus r. So the next term is n minus r. This is the next term than that. Again n minus r 1 I have to reduce. So it is n minus r minus 1. And so on till 3 into 2 into 1. So I want to write this in terms of the product of first n natural numbers. So wherever it is there I will keep, and the next terms I will multiply as well as I have to divide the same thing. Okay. So multiplying and dividing by what? N minus r into n minus r minus 1, so on, n minus r minus 2, so on till 3 into 2 into 1. Or you can write n minus r whole factorial, because we are multiplying from here, right? N minus r, so on till 3 into 2 into 1. So it is exactly equal to n minus r whole factorial. So you can write that also. Okay. Therefore we get npr is equal to n into n minus 1 into n minus 2 into n minus 3, so on, whatever I had there before. N minus r plus 1 I had, but I multiplied n minus r into n minus r minus 1, so on till 3 into 2 into 1, and I have divided also. So divided by, what is that, n minus r into n minus r minus 1, so on till 3 into 2 into 1. Therefore, what is this equal to? Numerator is exactly equal to n factorial, right? Denominator is exactly equal to n minus r whole factorial. So we got the formula for number of permutations of n objects taken r at a time. Okay, and condition for r is less than n or greater than 0, less than n, and it can be equal to also. Why? Because see, whenever you use this formula for r is equal to 0, what will happen? When r is 0, what will happen here? We get n factorial divided by n minus 0 whole factorial. So you get n factorial divided by n factorial, that is equal to 1. So whenever r is 0, we get npr is equal to 1, isn't it? And whenever we get r is equal to n, what will happen? Whenever r is equal to n, we get this as n factorial divided by n minus n whole factorial. So you get that is equal to n factorial divided by 0 factorial. What is 0 factorial? It is equal to 1. So we get that is equal to n factorial. So it is n is equal to n factorial. So both the values we know. Sorry, here it is np 0. I have taken this as 0, isn't it? So both are defined whenever r is equal to 0 as well as when r is equal to n. So this is also defined. Therefore we take a condition for r between both greater than or equal to 0 as well as less than or equal to n. Okay. So this derivation you should study for the exams. Clear? Now let us move on to various types of permutations. Okay. Here we have seen what is the formula for permutations of n objects given where r objects are taken at a time. Now see various types of permutations are there. In that the first one is the number of permutations of n different objects. This is very important. N different objects taken r at a time and where repetition is allowed. See, same formula we had there, isn't it? That is also the formula to find number of permutations of n objects taken r at a time. But here repetition is not allowed. But here repetition is allowed. Only that difference is there. Okay. So both are same, but only repetition of the objects here there it is not allowed, but here it is allowed. That is given by n power r. We have formula there, n factorial divided by n minus r whole factorial, like that. If the repetition is allowed, then we have the number of permutations, or formula for npr is equal to n power r. Okay. For example, find the 3-digit numbers which can be formed using the digits 1, 2, 3, 4, 5, where digits can be repeated. Say digits can be repeated is given. This you can solve by FPC also, fundamental principle of counting also, or you can use this method. Okay. So there are 3 vacant places, isn't it? So we have 3-digit number we have to find out. So 3 vacant places, and total how many digits are there? 5 digits are there, and this can be repeated. Therefore here this is place, or you can say 100 place, 10 place, units place. 100 place can be filled in 5 ways. As I can repeat the digits, 10th place also can be filled in 5 ways. As I can repeat the digits, units place also can be filled in 5 ways. Therefore, you need not write by FPC. By this method directly you can do. Okay, by FPC we are doing like this, or you can write this is by FPC. Right? Directly if you are doing, you can just compare this there. Okay. So find the 3-digit numbers where we can use the digits can be repeated and 5 digits are available. So it is 5 into 5 into 5, 3-digit number we want, right? So therefore, the number of or the 3-digit numbers required is equal to 3-digit numbers required is equal to what? You can directly write rather than FPC. You can go directly. So it is what? Number of objects available is 5, right? Number of objects available is n. So total 5 are there. How many has to be taken at a time? 3-digit number is required, so 3 has to be taken at a time. So value of R is 3. So 5 power 3 we get according to this formula, isn't it? What is 5 power 3? 5 into 5 into 5. What is that equal to? 125. Same if you are using FPC also you get the same answer. Okay, these are the two different methods. This is by FPC, this is by this formula. Okay, so we get both the answers same. Clear? Now let us move on to the next type of question then. Okay. Sorry, not question, various types of permutations. In that first type is one. Second type, the number of permutations of n objects, because here given objects are n, where some of the objects means p objects are of the same kind. Okay, when in that given n, if some are of the same kind and remaining rest are different, okay, then that is given by that number of permutations of n objects, where p objects are of the same kind is given by n factorial divided by p factorial. Okay, what is the use of this? Let us see in the example. Find the number of permutations of the letters of the word root. In this word you see how many r's we have. Only one r is there. Okay, in this word. How many o we have? There are 2 o's, right? And how many t is there? How many letters are there? I mean t, there is only one. See, in this there are 4 objects, isn't it? 4 objects are there. In that, one of the particular object is repeating 2 times. Therefore, the number of permutations here is number of permutations is equal to what? You have to use this concept, permutations is equal to. So what I have to write? N factorial divided by p factorial, right? So n is how much? 4 objects are there, so it is 4 factorial divided by, in that which is repeating, o is repeating 2 times, so p objects means there are 2 objects which are repeating. So we have to write 2 factorial. The value of p here is 2. Therefore, this is equal to 4 factorial is 4 into 3 into 2 into 1 divided by 2 factorial is 2 into 1. So it is 4 3s are 12. So this is our answer. Okay. The next type of permutation. The number of permutations of n objects taken, p1 objects are of one kind, p2 objects are of second kind, and so on, pk are of the kth kind, and the rest are different. Okay. If any are of the different kind, is n factorial divided by p1 whole factorial, p2 factorial, so on till pk factorial. Okay. How does it work? Let's see in the example. Find the number of permutations of the letters of the word institute. Now see, in this word, how many i's are present? I. The letter I is 2 times, right? So letter I is 2 times, and the letter N is only once, and letter S is only once, and letter T is 1, 2, 3, 3 times, right? 3 times, and I done, T is done, U only once, and T we have already taken, E only once, right? So these many repetitions are there. Therefore, how to write the permutations, total number of permutations according to the previous method? Okay, total number of permutations is equal to. So first you have to find out number of objects present, isn't it? So what is the number of objects present? Total 5, 6, 7, 8, 9, right? So 9 objects are present, so it is 9 factorial divided by, then repeating. See, I is repeating 2 times, see, one kind is repeating 2 times, so it is divided by 2 factorial. This is only 1, so 1 factorial is 1, you need not write. Once, no repetition. Here repetition is there 3 times, so 3 factorial, no other repetitions, right? So this is the number of permutations required. Now how to simplify this? What is 9 factorial? And whatever value you get, divide that by 2 factorial into 3 factorial. You get the answer as 30240. That is 30,240. You will get. That is the required number of permutations which will be used by, where we use this method to solve. Okay? Because there are some kinds of letters or the objects repeated. Okay? In that case only we can use this kind of permutations or this type of permutation. Okay, this is about different kinds of permutations. Now let us move on to different types of problems. Okay, how many 4-digit numbers are there with no digit repeated? Now see, 4-digit number, they did not give you the digit, isn't it? So actually how many digits are available? We know the digits are available from 0 to 9. Okay, these are the digits we use for forming a number, right? So we have to find a 4-digit number. So let me have 4 vacant places. So 4-digit number we want with no digit repeated. So we have to form this. No repetition is enough, right? Before going to that, say 0 to 9 is there. 0 is included here. So can I take 0 in this place? Not possible. Why? Because see, this is thousands place, 100 or 10 unit, right? So thousands place 0 cannot be taken. Why? Because among the 0 to 9 there are 10 digits. But among that 0 cannot be taken. Suppose if I take 0 in the thousands place, this digit whatever I get will be 3-digit number, but we want 4-digit number. Therefore 0 cannot be taken here. Therefore 10 digits availability is there, but I cannot take 0 here. So there are only 9 ways of filling, because 0 cannot be taken. The remaining 9 digits I can use here, right? So the number of ways of filling this place is 9. Think that any one of them I put here. Think from 0 to 9 I have put for example 4. Okay. So in this place 4 cannot be used, isn't it? For example I am taking, if I put 4 here among this 0 to 9, right? If I put 4 here, that cannot be used here because we know repetition is not allowed, right? So here how many ways of filling is there? We can fill this 100 place in 9 ways again, because 0 can be used here. 0 cannot be used here because the number what we get will be 3 digit. So 0 can be used here, and this only 4 cannot be used. Therefore again 9 ways are there to fill. Now 2 digits already gone, right? How many are remaining out of 10? 8 are remaining. So there are 8 ways of filling the 10th place. And this place, how many ways I can fill? 7 ways, because the digits cannot be repeated. Therefore the required 4-digit numbers is equal to required 4-digit numbers is equal to what? Is equal to, this is by FPC, right? By FPC you can write it. By FPC, therefore by your fundamental principle of counting, the required number of 4-digit numbers is equal to 9 into 8, sorry, 9 into 8 into 7. Okay? This you have to multiply. So you get this, when you multiply, you get this answer as 4536. Okay? So those many numbers you can find using for 4-digit numbers required here. Okay, let's go to the next one. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated. Next question let us see later. Now what we want? We want a 4-digit number, isn't it? So let me have 4 vacant places. So 1, 2, 3, 4. 4 vacant places I have considered. Now see, we have to get a number using these digits. How many digits are available? There are 5 digits available. So this is thousands place, 100 place, tens place, unit place. So how many ways I can fill thousands place? 0 is not there, no tension, like that. Okay. So 0 is not there, I can fill this in any one of these digits, right? So 5 possibilities are there. Then come to the next one. No digit is repeated. Therefore here repetition is not allowed. So I can fill the hundreds place in 4 ways. And this 10th place in 2 ways, and units place in 3 ways, and here it is in 1 ways. Therefore, the number of, or by FPC I can tell the 4-digit numbers, required 4-digit numbers is equal to 5 into 4 into 3 into 2, that is equal to 120. Okay, so this is the required number of, required 4-digit numbers. You can write here the required 4-digit numbers is equal to. Okay, first part is done. Now see the second part. How many of these will be even? Now among these numbers, how many are even we have to find. So for even numbers, what we have to do? See, 4-digit number only is required, isn't it? 4-digit number only is required, but the number should be even, right? So for even numbers, what we have to do? Look at this. For 4-digit number to be even, which place is considered? This place we should be very careful, isn't it? Here the number whatever you take, or the digit whatever you take, should be even. Therefore, how many ways I can fill this? Either 2 or 4. If I put here, then only the total number will become even number. Therefore, I have only 2 ways of filling this. Either 2 or 4. So, how many ways are there to fill this? Only 2. Right. Then come to the next one. So, units place is done. Now, 10, 100 and 1000. Right. So, tens place. Now, see. Any one of these will be gone. Right. So, how many ways I can fill this? See, among them 1 went. So, how many are remaining? Only 4 are remaining. So, 4 ways I can fill this. Then no repetition, therefore 3 ways. And no repetition, therefore it is 2 ways. Therefore, the number of permutations, right? The number of required permutations using FPC. You can write by FPC. The number of required permutations is equal to, or required permutations here. Permutations or required 4-digit numbers you can write. Okay, permutations is equal to what? It is 4 into 3 into 2 into 2, or you can write 2 into 3 into 4 into 2. Okay, so it is 4 into 12, 12 into 24, 24 into 2 will get 48. So it is 48 ways. Okay, or we can say total these many numbers are there and the repetition is not allowed, but in that 48 numbers are even. Okay. The next one, find n if n minus 1 p3 is to n p4 is equal to 1 is to 9. Now, whatever is given here, let me write n minus 1 p3 ratio and convert into this one, okay, division. n p4 is equal to 1 by 9. Now, this implies, use the formula here, n minus 1 p3, what formula is it? NPR. What is the formula for NPR? It is n factorial divided by n minus r whole factorial, right? The same formula I use here. I'll get n minus 1 whole factorial divided by n minus r. What is there in the place of r? Sorry, n minus 1 is there in the place of n, and minus r is 3. Whole factorial. Okay, divided by, what is it? NP4 is what? It is n factorial divided by n minus 4 whole factorial is equal to 1 by 9 as it is. Okay. Now see this. Denominator will be shifted to the numerator, right? So I get n minus 1 whole factorial divided by n minus 1 minus 3. So it is n minus 4 whole factorial, isn't it? And here you see this reciprocal act right here. So it is n minus 4 whole factorial divided by n factorial. Now n factorial I will write in terms of n minus 1 factorial because I can simplify that. Okay, this is equal to 1 by 9. Now cancel whatever you can cancel. N minus 1 whole factorial and n minus 4 whole factorial you can cancel. So what do you get? You will get 1 by n is equal to 1 by 9. So that implies the value of n is 9. Therefore, the value of n here is equal to 9. Okay. Next problem. Find r if 5pr is equal to 2 into 6pr minus 1. Now see from here I use the formula here. Okay. 5pr is equal to 5 factorial divided by 5 minus r whole factorial is equal to 2 into then 6 factorial divided by 6 minus r, right? In the place of r we have r minus 1 whole factorial. Now simplify this. You will get 5 factorial divided by 5 minus r whole factorial is equal to 2 into the 6 factorial can be written as 6 into 5 factorial divided by 6 minus r here plus 1 you get, right? 6 minus r plus 1. So you get that as 7 plus 7 minus r whole factorial. Okay. Now further when you simplify this you will get 5 factorial gets cancelled. When you cross multiply you will get this here. So it is 7 minus r whole factorial divided by 5 minus r whole factorial is equal to 12 you get, right? 12. But 7 minus r whole factorial can be written as 7 minus r into 6 minus r into 5 minus r whole factorial. Right, that is equal to 12. Okay. So 5 minus r whole factorial gets cancelled. We will get this as 7 minus r into 6 minus r is equal to 12 and simplify that. You will get 42 minus 7r minus 6r plus r square is equal to 12. Now simplify it further. You will get plus r square minus 7 minus 6 which is minus 13r, then 42 minus 12 which is plus 13 is equal to 0. Now factorize to get the value of r. Okay. So you get this as r square minus 13 can be written as minus 10 minus 3, right? Minus 3r plus 30 is equal to 0. Now the factors are r minus 10 into, here when you take r common you get r minus 10 and when you take minus 3 common outside here you will get r minus 3 as one factor, right? So from here we get r is equal to 10 or r is equal to 3. But which value of r satisfies this given condition you should see. See the value of n is 5 here and the value of n is 6 here. So value of n cannot exceed more than 5 or more than 6, right? So for that we have either r should be less than 5 or r minus 1 should be less than 6. Therefore from here we can make out that this implies r is equal to 3 only, as r cannot be equal to 10 because, what is the reason? Because r can be either less than or equal to 6 or 5. 5. Okay. So it can be either less than or equal to 5. Therefore r is equal to 10 is not possible. So the value of r is 3. So here you have to conclude properly. Okay. So therefore we get the value of r is equal to 3 itself. Now let's move on to the next problem. How many words with or without meaning can be formed from the letters of the word Monday, assuming that no letter is repeated? Okay, letters cannot be repeated, right? So here Monday, we have how many letters in that? In this word we have 6 letters, and all 6 letters are different, right? So the first question you see, the 4 letters are used at a time. Now for the first question, the required number of permutations, okay? The required number of permutations is equal to, so it is actually arrangement of 6 different objects taken 4 at a time, okay, 4 at a time, where the repetition is not allowed, right? So it is actually the formula, it comes under the formula NPR is equal to n factorial divided by n minus r whole factorial. So you can write this as 6 objects are available, but how many has to be taken at a time? Only 4 has to be taken at a time. So it is actually equal to 6p4. So what is the formula? 6 factorial divided by 6 minus 4 whole factorial. So we get this as 6 factorial divided by 2 factorial. So when you simplify this, you will get this as 6 into 5 into 4 into 3 into 2 into 1, and this is 2 factorial. So you get the answer for this as 360. Okay? So that is the number of required permutations where the 4 letters are used at a time. Now the second one, what that tell me? All letters are used at a time, means there are 6 letters, all the 6 letters are used at a time. That means the required number of permutations is equal to, how to write? The required number of permutations is equal to 6 letters are there and 6 letters, all the letters are used at a time, means it is 6p6, right? When you use the formula, you get 6 factorial divided by 6 minus 6 whole factorial, which is 0 factorial. So answer you get as 6 factorial divided by 1. So what is the value of 6 factorial? It is equal to 720. Okay. So this is the required number of permutations. Now the third sub question. What is told? All letters are used, but first letter is a vowel. Now see, all we want to form a 6-lettered word, right? So 6-lettered word we have to form. But all letters can be used, but the first letter is a vowel letter. In this word, how many vowels are there? O and A, isn't it? So first letter is vowel means here fixed. Which are the letters fixed here? Either I have to take O or I have to take A. No other option because they told first letter is a vowel. So either I have to take O or I have to take A. So how many ways are there to fill this place? Only 2 ways. I cannot use my wish, right? M I cannot use, N, whatever is there. I cannot use, I have to use first letter is a vowel means only vowels can be used here. So there are only 2 possibilities of filling this. So repetition is not allowed. Therefore, whatever vowel I use here, it cannot be taken here, isn't it? So among those 6 letters, 1 went off here, right? So how many are remaining to fill the next place? Only 5. Again, repetition is not allowed. So these 2 I cannot use. Therefore, how many ways I can fill this place? 4 ways. And like that, we can fill these places in these ways, right? Therefore, the required number of permutations here is equal to, or required number of words you can say, okay? Permutations is equal to, it is 2 into 5 into 4 into 3 into 2 into 1. Otherwise, you can do 2 into 5 factorial. These 5 places can be filled in 5 factorial ways. Therefore, it is 2 into 5 factorial, or you can do like this, okay? So, you get this as 2 into 5 into 4 into 3 into 2 into 1, okay? So, 5 factorial is 120, so you have to multiply 2, you get 240 ways, okay? So, this is the required number of permutations in this case.